Right, guys, let's go ahead and do our study guide. I'm going to go through the even problems. The odds are there for extra practice. If you're interested, the answer key for those is provided. So, for number 2, we're going to be starting off with doing integration of trig functions. And a lot of times, these are going to be u subproblems. And the u is going to be the part that is inside of the parentheses. So, let's take the derivative here. And take the derivative of e to the 4x. You just get e to the 4x. That's the derivative of the outside function. But the derivative of the inside is 4. So you get 4e to the 4x. And when you take the derivative of the 2 there, it just goes away because it's a constant. Alright? The next thing you want to do is get the dx by itself. So if we did that appropriately, we would end up with that. And then we're ready to do our u substitution. So the negative 8e to the 4x is still there. And we have secant squared. And we're replacing all that with u. And we're replacing that with du over 4e to the 4x. The e to the 4x's go away, and 4 goes into negative 8, negative 2 times, and putting the negative 2 outside of the integral leaves us with that. All right, and then the integral of secant squared is tangent. And then finally, we're just going to replace the u with the original value of u, which is this. And then we're all done. So that's how the trig integration is going to work. You're going to do your u substitution and then integrate. Let's take a look at number 4. So for number 4, we have cosecant and cotangent being multiplied together. Now there is an integral that has both of those in it, and so my u is going to be the 3x squared minus 1 there. So now you might be thinking, which 3x squared minus 1 is it? Is it this one or is it this one? Well, the answer is it doesn't matter. Just we know that the part inside the parentheses is 3x squared minus 1, so that's my u. So my du dx is going to be 6x. And then getting the dx by itself, we have that. Now we're ready to do our substitution. So the negative 30 is still going to be there for now. Then we have cosecant. And instead of all that, we're going to put a u there. Then we have cotangent. And then instead of all that, we're going to have a u there, the same thing. And then instead of dx, we're going to have du over 6x. And I just realized that I left off this x here, so I need to squish that in there. All right, so now 6x. Well, the x's go away, and 6 goes into negative 30, negative 5 times. And then we're going to pull the negative 5 out to the front. And this is a standard trig integral. That one actually is negative cosecant. And then negative 5 times negative 1 is going to leave us with a positive 5, cosecant. And then instead of u, we'll put back what the u equals, which is 3x squared minus 1. And so there's the answer to number 4. Go ahead and take a look at number 6. One more trig integral. So we have u is equal to e to the 5x plus 2. derivative of the outside, the e function is just the e function, multiplied by the derivative of the inside is 5, and the 2 just goes away because it's a constant. Getting the dx by itself, we have that. We're going to bring our 20e to the 5x here. That's this guy. Then we have cosine. And we're going to replace that with the u. And then we're going to replace that with the du over 5e to the 5x. The e to the 5x's go away. 5 goes into 24 times. And then that 4 comes out of the integral. The integral of cosine is sine. And then replacing the u with the value of u, which is e to the 5x plus 2, gives us our final answer, like so. Let's go ahead and take a look at number 8. Getting into the arc trig stuff. As you guys can see, this fits the arc secant pattern. So, we have 3 blanks we need to fill in. 1, 2, and 3. So what goes in those spots? Well, actually up here, there's absolute values as well, by the way. On the top, we just take the square root of that, which is x, so that's what goes there. And then 2 bottom numbers are the square root of this, which is just 1. Now we can simplify that and just end up with secant, arc secant, of the absolute value of x plus c. Number 10. Another arc secant. Well, no, I'm sorry, not arc secant. This one's actually an arc sine. So with arc sine, there's nothing in the front of it, but we do have a top number and a bottom number. The top number is the square root of the x term. Bottom number is the square root of the numerical term. And so if we just wanted to write it in a more simple fashion, it would be this. Go on to number 12. All right, so for these types of problems, we want to do like a u sub. This looks like an arc secant, but there's a couple of problems. First of all, you're only supposed to have a number in the top, not a variable. And also, this is supposed to be a square, not a 10th power. But whenever we see those two things, that's usually an indication that we're still going to do arc secant, but before we do, we're going to go ahead and do some u sub first. But before we even do that, what we're going to do is we're going to rewrite it a little bit. I want to rewrite this piece here as a square. So what number to the second power would give me 4x to the 10th? Well, basically, we just need to take the square root of 4x to the 10th. And when you do that, you take the square root of the 4, that's 2, and cut your exponent in half, and that's 5. So that's what's going to go in here, is 2x to the 5th. And that is what our u value is going to be. Okay, so step 1 is to rewrite it. Step 2, u substitution. Here we go. Now we're ready for plugging the stuff in. We have our 10x to the 4th on top, 2x to the 5th on the bottom. We're going to replace the 2x to the 5th with a u squared. And as a matter of fact, I just realized this is also a 2x to the 5th, so we're going to put our u out here also. And then we have our minus 9 here. And we're going to replace the dx, which I forgot to write over here, but we're going to replace that with du over 10x to the 4th. And those go away. And now after you do your U substitution, it should look more like a normal arcsecant function. We have just a number on top and a square on the bottom instead of a 10th power. So from there, we're ready to go ahead and do the arcsecant. And remember, we're going to have a number on the top, a number on the bottom, and another number on the bottom here. The number on the top is the square root of this number, which is u. The number on the bottom is the square root of that number, which is 3. So I've got 1/3 arcsecant of the absolute value of u over 3. And I'm going to replace the u with what u equals. And don't forget, if you ever have an even power here, you can get rid of the absolute value bars. But if it's an odd power like we have, we leave the absolute value bars. Go ahead and take a look at number 14. All right, so this is a definite integral. So the first thing we're going to do is we're going to integrate this integrand here. And that's just an arcsecant. So the square root of this number goes here, and the square root of this number goes here, and over here is a denominator. We don't need a plus c when we do definite integrals. Now, also, I'm going to rewrite this a little bit. We really don't need this 1 over 1 here. We don't really need that 1 there. So if I were to rewrite this in a little bit more of a simple-looking fashion, we would really just have this. So now applying the fundamental theorem of calculus, we end up with arcsecant of 2 minus arcsecant of 2 radical 3 over 3. Okay? Now, try to use your chart and circle to figure this out. But arcsecant is a little bit more challenging than arcsine is, so or arctangent. So I'll explain it, how to do it, but once again, it is on the charts. So first of all, I'm going to focus on this one. I want to know, what is arcsecant of 2? Well, we can rewrite that as a normal secant if we just switch the question mark and the 2 around. Now, secant is the reciprocal of cosine. And then if I just flip this side over, which I'm allowed to do, so long as I flip this side over, we're good. So I'm looking for what angle would give me a cosine value of 1/2. So I'm going to look at my unit circle. Now cosine has a value of 1/2 in 2 spots. One place is here, and the other place is down here. Now we have to remember that when dealing with arc functions, arcsecant is restricted only to the top half of the circle. So I won't be using the bottom, right? So that means my answer for that one will be the angle at that spot, which is pi over 3. Okay? So that's the angle that would go here that would give me that cosine value. So this is pi over 3. And repeat that process for the next one there. So, arcsecant of 2 radical 3 over 3. We want to know, what does that equal, right? So same thing. I'm going to change it to a normal secant instead of an arcsecant, which I'm allowed to do so long as I switch the question mark and this guy around. The next thing I'm going to do is, you could look at the chart that you guys have also. The downside of doing it is that you have to make sure you stick only to the top half of the unit circle. But anyway, back to this. That's 1 over cosine, right? Then we take the reciprocal of both sides. Now we don't like leaving radicals on the bottom, so I'm going to multiply the top and the bottom of this thing by radical 3, which gives me the following. And that reduces to this. So basically I want to know what angle has an x value of radical 3 over 2. On my unit circle, cosine, or the x value you could say, has a value of radical 3 over 2 both here and here. But remember, with arc trig functions, we're only allowed to use the top half of the circle. So this is my answer, and the angle at that point is pi over 6. So pi over 6. All right, so that's that. So we have got pi over 3 minus pi over 6, multiplying the top and the bottom by 2. Final answer is pi over 6. All right? Now some of you guys might be thinking, Mr. Bailey, didn't you say it's the right half of the circle and not the top half? Well, that's true for arcsine and arctangent and arccosecant, but arcsecant is the one that'll be on the top half of the circle. All right, let's go ahead and take a look at number 16. Now, this almost looks like it would be an arctangent problem, but it's not, because there's an x in the top. But we do have a square. These last ones are actually not arc trig functions at all. What they are is they're ln problems. So I'm just going to let u be equal to the bottom half. And then I'm going to let dx be equal to du over 2x. And so if I do my substitution, those cancel out, and you're left with 1 over u du. Okay? So that's an ln problem, which is going to be ln of the absolute value of u plus c. And my u value is x squared plus 4. Now, we don't really need the absolute value bars on this because that's always going to be positive, and I'm adding a positive to it. So since that expression is positive no matter what, this is a better way to write the answer, but technically either one is right. Okay, so number 16 is an ln problem. Let's go ahead and take a look at number 18. Number 18 is another ln problem. I'm going to let u be equal to the denominator. Now, when you take the derivative of this, just like the one we did in class recently, we do the derivative of the outside, which is cosine. And then you multiply that by the derivative of the inside. And then we get the dx by itself, which would look like this. Doing our u substitution then, we have 12 cosine of negative 3x over u du over, I forgot my little negative here in the front, so like that. But du over negative 3 cosine of 3x. So the cosine of 3x's go away. 3 goes into 12 4 times, and this negative cancels out that negative. So here's what I'm left with then is 4 over u du. And that 4 we could just bring right out to the front, and so we have our regular looking ln expression there. So we have 4 ln of the absolute value of my u plus c. Finally, u is equal to sine of negative 3x. And we're all done. All right, last one we'll look at for today, number 20. When you have a trinomial in the denominator like this, this is the one where you're going to start by rewriting it like this, using that process known as completing the square. Okay? Now, first of all, before I do that, though, notice that we've got that and that. I'm just going to pull that negative and 5 out to the front is negative 5, and I'll put a 1 there. But let's go ahead and do our completing the square here. So the first thing that we do is we take that 37, and we're going to push it off to the side a little bit. Because we're going to create a new number there. And we get that new number by taking half of 12, which is 6, and then squaring that, which is 36. You're also going to put that number over here again, but this time it's going to be minus. This is a perfect square trinomial, and I gave you guys a shortcut for factoring those, and they will always look like this. The only thing we have to figure out is what number goes there. And that number will always be half of the middle number, which we already said was positive 6. These two come together to make 1, and we have now successfully completed the square, and that's what goes here. Okay. So step 1 is to complete the square and rewrite it. Step 2 is to do your u substitution. My u is x plus 6. My derivative of u with respect to x is 1, which means that du equals dx when you get dx by itself. So we have the following. At this point, it is an arc-tangent problem. Okay? So we have negative 5. The number on top is going to be the square root of that. The number that goes on the bottom is the square root of that. And arc-tangent also has 1 over the square root of this number, which is 1 also. We can simplify this a little bit, though. And then finally, we can replace the u with x plus 6. And that's that. So, there you guys go. And we'll see you guys in class tomorrow.